Welcome to my kitchen. Welcome to my hackathon submission. You're going to witness the least delicious cooking show you will ever see. We are serving up an AI that detects phishing sites faster than you can say, wait, is that really my bank? Or is he the true Nigerian prince? The objective of this video is really simple, just to show you a demo of an AI-powered browser plugin where we fry the scammers before they fry your data. Today, I will show you how we trained an AI chef to sniff out phishing websites and keep your internet meals safe. Every great dish starts with the right ingredients. We gather a data set full of both tasty, legitimate URLs and some seriously spoiled phishing ones. This data set, the main one, whatever we have used, is from UCI machine learning repository, featuring over 250K URLs and 30 different features. Basically, it is a Michelin guide for good and bad websites. We extracted some key flavors, key features like URL length, subdomains, HTTPS present, and whether the domain smelled fishy. Because let's be honest, if your bank website has 14 dashes, 6 subdomains, and a .xyz domain, it's probably not your bank website. One main problem we ran into this data set is it has too many phishing sites and not enough legitimate ones for machine learning algorithms liking. To avoid many false negatives, we added a list of trusted domains. That list of trusted domains is coming from SimilarWeb, the top 200 ranking website based on the number of visits it had in the last couple of years. Now, we couldn't just throw raw data into the pot and hope for the best. We had to train our AHS. We tried every algorithm from grandma's cooking recipe to tech bro smoothies. When I say grandma's cooking recipe, it is random forest to XGBoost. Turns out AI hates phishing sites more than millennial hates phone calls. We reached almost like 99% accuracy. Among all, random forest and XGBoost performed exceedingly well, but I picked random forest not just because of personal inclination, but also because XGBoost had an audacity to flag Wikipedia and Google as spam. Better accuracy matters. That's the reason why I went with random forest for this particular plugin. What is the use of five-star dish if no one gets to eat it? We deployed our model using Flask API and built a Firefox web extension. Why Firefox? Because I needed an easy way to offload the extension without having to install it permanently, just for this demo. Now let's start cooking. Before that, I'll quickly show you the data set that we have used and the trusted domain list I was talking about. These are the two data sets that are being used in this machine learning algorithm. As you can see, these are the main data sets where you can see URL length, domain, and multiple other probabilities which define the legitimacy of that particular URL. And at the end, you'll be able to see an indicator to see whether that particular URL is legitimate or is a phishing website. And at the bottom, you can see the trusted domains. It has around 200 plus trusted domains from where the websites are considered legitimate. These are all the data sets which are used in our training. Before training the model, I just wanted to do a quick comparison across all other algorithms. This is the final result. Random Forest and XGBoost performed really similar, exceedingly well. But I picked Random Forest because I will be able to manage the importance of the fields, importance of the features better in Random Forest. First, we have to train the model. As I mentioned earlier, we are using Random Forest algorithm because it behaves well. Once the training completes, it creates a .pickle file, which we will use to start the Flask API. As a part of the training, you can see the result, accuracy, precision, everything. Along with that, I'm printing the feature importance also. You can see all the 7 features, and all are sorted based on their importance quotient. You can see is trusted, is being treated as low priority, which we will have to increase the priority as a part of our app program, app Python program. Now, this is our app.py. This uses the pickle file generated in the training section, and also it uses the trusted domain text file that we discussed earlier. What this API actually receives is, it actually receives a URL from the browser, and it will analyze each of those features, send it to our model, and it will predict whether that URL is legitimate or is a phishing URL. I have added the health check also, just to make sure if it is everything's working fine, and I have enabled the verbose login so that we'll be able to see all the values that API transfers back to the browser. Now, let's start the API and check the health in the web browser. API is started. Let's check the health. You can see phishing directory service is already running fine. Next step, we have to side load our browser extension in Firefox. This is the plugin we are going to side load into our browser. I created 2 different versions. One is for Chrome and Edge, and another one is for Firefox. The reason why Firefox needed special attention was the manifest.json does not support manifest version 3 in Firefox. Okay, and I find it's easy to side load temporary plugins in Firefox. Now let's side load the plugin in Firefox. I'm loading a temporary add-on. I'm picking that manifest.json. Yes, it's loaded. This is our icon. I'm pinning that to toolbar. Okay. Until I close this browser session, I will be able to use this plugin without any issue. Now it's time to test it. Our API is already running. So let me try to get into a website, say YouTube. As you can see, phishing detector, it says the site is legitimate. In our API logs also, you are able to see the features extracted, like what is the URL length it received, what is the domain length, what is the subdomain length, whether it's a legitimate one or whether it's a part of the trusted domain, that is the last one, and what is the raw phishing probability, things like that. All these are being sent, and the prediction is it is legitimate. Let me open one more. I open TurboTax because it's tax season. You can see it's classified it received TurboTax and it received legitimate. The phishing probability is 0%. Let me open some fishy website. I will make up some fishy website with double dots, with alphabets, things like that. I'm not going to use a real phishing one. I'll just make up something really fishy one. Okay, again, so, yeah, as you can see, you're getting a warning message. It stopped you from getting into that site. You got a warning page. In our logs, you should be able to see the phishing probability. You can see that the site, whatever you entered, here are or 0 is classified as phishing one. So it redirected to the extension. If you still want to proceed, you can click on the proceed anyway function. Now, let me actually try a phishing site, like site that is actually classified as phishing one. Okay, that one is also is flagged, and it is not letting me go through. Let me check the phishing probability. As you can see, I tried this music production guru, something like that. I don't know about this site, but in the website, it is classified as phishing one. So the phishing probability is one, and rightly so, it is flagged from proceeding further, which goes to show that this plugin actually works. That concludes our demo. I have provided all the scripts, data sets, models, and README files in GitHub repository for your reference. If you have any questions, feel free to reach out to me. Thank you. Bon appetit.